guys, I have been streaming this thing for two already times, and I forgot to click this begin stream button. Damn it. Damn it. I'm gonna get me some tea and I will continue. this is some kind of a real mess I'm getting. It- that means I'm going to start this thing like for the fourth time already. So the first time I was missing clicking a go live button inside OBS, which I'm using to broadcast here. The second time I have missed clicking the go live button inside the YouTube channel panel. And then I forgot this sound and damn. Sorry guys. So I'm gonna start again. Damn it. Yeah. So basically I was talking about how I would start the game when I'm trying to count the performance. Um, so I'm using this thing called Riva Tuner Statistics Server, which is basically controlled by the MSI Afterburner. I pretty much think you know what this thing is, because it's pretty popular within the gaming community, and pretty much everyone uses it, not only those who use MSI products. And what it allows you to do, it allows you to get all sorts of monitoring. It allows you to get like CPU, GPU, memory usage, everything you need. And this thing is actually a bomb or a blast. I don't know what's the word for the current term for something being very awesome. And it basically allows you to get an overview of the performance that you're getting from your solution, from your application. Of course, I could use the profiler inside Unreal Engine, but it's pretty heavy, you know? It's pretty heavy both in terms of its usage, so you have to like get bunch of scopes of counters, maybe some timers to pull that off. And it also has quite a nasty footprint on the end performance of the system. This Riva tuner is actually quite lightweight, so I'm using it like all the time. Of course, if you're going to pinpoint the exact feature, the exact logic that's lagging you behind, you have to get deep and to use the Unreal Engine's profiler, or maybe another kind of profiler out there. But if you want to get like overview of what performance you're getting, you're fine using these tools. So the Riva Tuner is basically the overlay engine, so to say. And the MSI Afterburner is like a useful and user-friendly controller for this thing. So yeah, in order to get these values that are currently shown here, you have to make them explicitly in the overlay panels on-screen display by checking this flag here for all of which you're going to use. Yeah, so I'm getting all sorts of stars here, and let's run this thing in a standalone mode. Yeah, so I'm selecting the standalone mode, and let's run. So I'm running this thing for a fifth or fourth time already. All right. Finally, we're here with the sound and with the whole stats panel, because everything just doesn't seem to work, either hardware, software, or Vladius himself. Oh well. Um, let's go by examining the first row here. So it's basically GPU. The temperature of the GPU, you're basically fine if you're getting below 75 degrees or even a bit higher. The lower the better, obviously. Then you get its utilization. It's about 30% right now. So you're pretty much not GPU capped at all. And you should know that. Then you get these basically ticking clock for the GPU. So all of the processors are basically like a ticking machines. So they launch some calculations, some processing by essentially on a ticking basis, so to say, like your actors, for example. These are more complicated, of course, but yeah, this is the amount of ticking you'll be getting at a second. Then there is a wattage usage, so how much the power and actual energy your CPU or GPU is pulling from your PSU. And these are actually correspondent or related or proportionally like are proportional to the clocks that you'll be getting. The more clocks you're getting, the more wattage you're getting. Of course, there are other factors here, but yeah. Then you got the memory usage. So this is the memory for the GPU. We get like about 2 gigs of RAM currently used, and a bunch of stuff actually is going here, including the frame buffer itself. So the screen you're looking at is actually in the video memory right now. Uh, lots of other stuff like the windows, the textures, the Unreal Engine itself. Everything goes to this GPU memory. And there is the clock for the GPU memory, of course. It's pretty high. About 7 to 5 megahertz. Then goes the CPU. It's at 62 degrees right now. Again, everything below 75 should be fine. The lower the better. Then goes the CPU utilization, which is now at about 7 to 9%. So it's about 8% on average. And what does this thing actually means? Well, it's not obvious that we are now CPU capped, isn't it? Because we pretty much the CPU utilization is lower than the actual GPU utilization, but we are exactly CPU bound right now. And how would you actually understand this? Let's go the resources monitor or process monitor. And yeah, you will be getting around the same 10%, say, here. But you shouldn't like believe this value. You go here to the performance tab. So again you will be seeing something like that. And then you should really go to the resource monitor. And here you will start with overview most likely, but you should switch to CPU. In the CPU tab, you basically like having you're having the same again. You're having the same 10%. But again, you shouldn't believe this value, and you should scroll down and see that there are certain CPUs that are actually struggling. So I have a 5900X AMD CPU, which has 24, yeah, it's 24 minus 1, so it's the last one. it's zero based essentially. So the first one is 0, so it's 23 here. I get 24 different CPUs, 24 threads on this CPU, and I actually have 12 physical cores and 24 the hyper-threaded ones, so virtual ones. And the most important factor is, of course, the physical core count. So if I look at this CPU here, we can see that the actual load is distributed between these two. So once this is high, this is low. And once this is low, this is high. That basically means that it's a single physical CPU that's distributing its load between two virtual ones. So in order to analyze this load value correctly in a single threaded application, because we are now going with the single threaded scenario, because basically all we have is a simple loop which is executed in a single main thread or the game thread. It's called like that in Unreal Engine. Then we have to do what? We have to exactly divide a one core by the 12 available on my system. Again, this is physical. These are physical cores. And I will be getting about 8%. So I can multiply it by 100. Yeah, about 8.5%. And that's exactly what's shown here. So these 8% here is actually capping the whole, well, it may seem it's not that important, not that large of a value. It's actually capping all of my systems. So I'm currently CPU capped, and this single core is lagging behind all of the process. Yeah, so for example, what does these milliseconds actually mean? Say 10 milliseconds. Those are actually FPSs. So if we divide 1000 milliseconds, that's the amount of milliseconds in 1 second. If we divide it by 10, we get about 100 FPSs right now. And it's pretty okay, isn't it? Everything about 60 FPS is pretty much standard these days. So in order to get 60 FPS, we must be at least at 1000 milliseconds divided by 60 FPS. We have to get about 60 milliseconds. So it's pretty much 60 FPS then. Some people actually like to display the actual FPSs here. I'm usually fine with the millisecond count. You can choose whatever you like. Again, if we're going to this MSI Afterburner thing, I think it has an option to display the FPSs. It's not that I need it, but just in case. Frame time, yeah, there is a frame rate also. Yeah, so it's about 100 FPS. There is also some stats for minimum and maximum. Let's show them as well. I think we get space for it. And some frames below 1%. These can be useful as well. Well, why didn't they show up? That's strange. Well, anyways, we don't really need those really. So, just to make sure, let's actually increase the count for the active entities. I don't know if this got on the camera, so I'm going to repeat this. I've basically refactored my data size to be a dynamic U property, so I could actually change it from the editor, from the details panel. So I'm going to make it twice as much. Let's get it to, damn it. Let's get it to about 2 million then, and launch this again. How's the stream actually, technically wise? Is everything fine for you? Just making sure everything is in sync and well executed. So now we'll be getting about twice as much milliseconds, so about twice worse FPS actually. So we got around 100, and now we get about 50. That's pretty logical because we pretty much increased the entity count twice, so we get like 2 million right now. And this is what we are getting when we are using the standard arrays, the standard C only for loops. And an important thing is to, I don't need those, I think. An important thing here is now to understand how much of a footprint. This is some kind of a ideal scenario for iterating things. So you can't get better than this. The for loop, the C++ for loop is pretty much the target to achieve for every iterating process, be it ECS implementation or ECS implementing or something else. And well, spoiler alert, Apparatus is not that effective, of course, and we are going to see right now how much of a footprint we'll be getting with Apparatus. But the important thing here is that this for loop is not really that functional in terms of the end the end logic that you're going to implement game-wise. So you're only getting like basic functionality here. You don't get like flag mark skipping. You don't get like ranging iterations. You don't get you basically can't skip, and you don't know you can't skip. You don't know if an entity was actually deleted from this array, so it's no longer viable and should be skipped. Lots of stuff actually is happening within Apparatus that makes it less effective in terms of this scenario. But let's see for ourselves what kind of footprint we'll be getting from this simple scenario. So I'm gonna halt the execution right now. Let me just make sure everyone is here who was willing to participate. Fine. Yeah, what we are going to do is just basically spawn some of the entities. Let's do this. So we are going to include the machine. Again, he's not seeing anything because of these issues in the C++. I don't know why. Could not be found. Why? Because it's certainly there. Could not be found. Compile comments default. What? Making sure everything is actually. Ah, damn it. Let's rescan that. What's wrong with you, man? So it basically just can't go on and find the compile counts default, which is pretty much specifying all the include paths that are needed to compile these files. So I'm going to be getting this. Why is that full path? Cannot find. What's wrong? Well, it certainly can't find the file within spaces, I suppose. What's configuration with compiler path? Oh. So maybe you shouldn't install Unreal Engine inside these program files folders. Still, this is a piece of garbage. Okay, forget it. Sometimes it works, sometimes it's not. Well, let's try another thing. Actually, the C++ plugin can work the other way around. You can actually parse C++ solutions. Machine H doesn't know such file or directory. Why exactly am I becoming dumber or something? Let's try this one. Workflow. Apparatus is enabled. Okay. I'm gonna switch to the Visual Studio right now. Let's get it like this. Let's restore it. No bother. Can we get the solution right now? No, we cannot. What if I'm just deleting this folder? That's for good. No, it still doesn't. What is this thing? Let's go to the preferences then. Let me just Google this one. So it's not even in the project, so to say. Never give up so easily. So it's C properties, but there is no such. Okay, so let me do this here. Where is Clang or OC compiler actually installed usually? Let's Let's see this. Where is actually it's contained? So if I'm going to program files, visual, something, well, it's always hard to, so hard to find. Damn it. How would you actually find this thing? Visual Studio Compiler path. Why does it always has to be this way? It's so better with all the open source. Why does it has to be this way? Oh, damn it. Stupid idiot. Always forgetting his login. Uh-huh. Microsoft Visual Studio. So no, I'm pretty sure it's not like this anymore. No, it's nothing like that. It's no longer viable, I think. So shall we copy this one here? Damn it, why are you so stupid? Let's reboot this thing. Are you kidding me? Maybe this one helped. Oh, that's a new one. Uh, I see it's pretty much an Unreal Engine's bug. So I won't be able to get this. Well, anyways, we don't need it. These really can go without. Yeah, I'm smart as long as I can compile this thing. Certainly, yeah. Man, I've dealt with so many of these. Oh, now it's what? So it was like, wait a minute, wait a minute. It's not like we're completely doomed. It's only about me forgetting this tiny exe thing. Maybe. Maybe. I don't get it. Hmm. It used to work fine, just not anymore. Oh well. Let's generate the Visual Studio Code project then. No, it's not. It's not hooking it. This thing is pretty useless. Get it. So what's wrong with including the machine then? Wait a minute. Should be pretty basic, you know. That's just making me... No, of course not. Of course not. Hey, Alexei, what am I getting? What am I, the creator of this whole thing, getting wrong about including the thing in the first place? Didn't we get it like this before? Or maybe it needs some like global stuff? I don't get it. I really don't get it. Isn't like how we always did these tutorials, so it was fine before. Like details, for example. Yeah, it should be just including the detail. What's happening? I don't get it. Is this something about the project? Hmm. What is exactly wrong here? No, I'm just giving up. Of course, we are always using this Git version, but it should be fine. Maybe build. Sorry. Okay, of course, plus this one. Should be fine now. Yeah. So basically this thing is like a C sharp. Well, UBT in general is like a build tool essentially. It's a bit of a headache certainly, but it's pretty much generating the whole infrastructure of CMake or other build files, intermediate build files. So it needs to know what modules you're actually using, and these are not based on the settings in your Unreal Engine in your project, unfortunately. So even if I have reference here for the Apparatus plugin, it's it still has to be included explicitly within this build CS file. Otherwise, it won't see it. And if you're like using a bunch of stuff, like maybe some private inclusions, well, the private is, well, the public ones are those that actually should propagate to the users of this module. So if this module was a plugin of itself and had some public dependencies, the other modules would also include those. Those include paths would be inherited, so to say. And these ones, they're pretty public to me, so I'm gonna use it like this. But also I could like just bring them here into the private dependencies, because this module is not actually going to be shared. But anyways, yeah, you should include the apparatus runtime right in this one. If you're going to have like an additional editor functionality based on the apparatus editor for these module rules, if you get apparatus footprint editor module, you also have to include the apparatus editor here. Yeah, so basically this. Phew. Yeah, Alex, I've managed to cope with this thing. Да я ж просто на самом деле, как бы это, надо это из сорсов все ставить, и никаких проблем не будет. Anyways, let's go forward, shall we? And now we should generate, if we were like allocating this plain array before, now we're going to generate, let's define actually plain array. So it can be conditional. Oh, it can actually be runtime conditionable, I think. So let's get a boolean then, which will be called plain array mode. Let's even prefix it with the B according to the Unreal Engine's standard naming. Here we go. Otherwise, we're going to create a bunch of stuff in Apparatus itself. So this chat, yeah. Let's bring it here. So this is data, and now we're going to span a bunch of things with the help of Apparatus. So in order to spawn something, we actually need a mechanism for it. So let's do this. Let's do this for our world. So mechanisms are now world-based, essentially the world states of the apparatus. So you can have multiple worlds, multiple mechanisms. They can now actually also be package-based, so you can have like some kind of a offline out of this world mechanism. Everything is possible right now, almost. So I'm going with the world here. So basically there is, since this is actually an educational stream, internally there is a dictionary of mechanisms which are essentially associated with some kind of world or some kind of package, some kind of Unreal's world and some kind of Unreal's package. So you can get like all sorts of layers in your in your application or game. This can be pretty useful, you know. The second thing now, this is about actually spawning stuff. So I'm gonna spawn in the loop. This is only for the demonstration purposes. So I'm gonna start with this. Yeah. And now just mechanism spawn subject. Really, that's all we need. And yeah, I should be creating a detail or trait, because we are like cache orienting here. I'm gonna create a trait. So let's call it like, for example, measuring, not measuring exactly, but well, let's call it vector trait. Pragma once. Well, I could use a template that's available here. So I'm going to use this one. Just copy this. Maybe you're not actually coming from a C++ world, so I can like show you what's all of these things are. Well, basically pragma, well, this is a comment, so it begins with double slash. It doesn't belong to a code really, just some annotations here. The pragma once pretty much states that this file should only be included once. Basically for all the header files you just have to like snap this one. The next two are this is coming from Unreal Engines. Well, these includes are basically modules, so you include them for functionality. And the second one is always named like the file itself or the class or the struct itself. So if it's vector trait, we have to name it like vector trait. Then there goes the struct or class itself. This is basically a comment also. It's also in green. We can call it like the test trait to measure the performance on. And this is going to be called like we also need to have it with this API thing. That's basically the type of module. This is needed for the linker, for the C++ linker. And it tells where the symbols, where the methods of this function actually declared. So we gotta have this one here. And let's call it vector trait. And here are the fields that are part of this vector. Let's get it to tabs. So I converted these to tabs. This useStruct specification, it's actually a macro that's telling the reflection system of the engine, the system which describes which types are what types are what they consist of, what fields do they have in. That's Unreal's way of doing such stuff. And this one is for the Unreal header tool, which generates these kind of files. These are the system ones. So basically, you just go on with this template and change it accordingly. So U properties here, it can be changed anywhere, including the blueprints. And I need a vector just to be symmetrical to the measurer here. And this one, yeah, this was plain 3D vector, so we're going with this one. F vector, oh, vector, yeah, that's okay now. And now we're going to continue with this measurement actor, which now spawns the class, and we're going to call it, we first need to include the vector trait here, and now we basically have to spawn it here. Vector trait, let's say it's f vector 0 vector. Okay. Now the same logic as it was. We are going to just increment the stuff. So we are saving the previous functionality in order to do the A/B testing. And now we're making the iterating thingy. Or yeah, we are going to do this in the operating mode. So let's do this. Let's go with mechanism and chain. Let's do it in a solid way. And here goes the filter. Can even use a newer to filter. Here we go with the F vector trait. And then the operate clause. This is lambda basically. So yeah, we don't need any state here. This is going to be empty. Now the arguments. We need a vector trait. So let's bring it out here. Now for this vector trait, it has a vector inside it, so we're going to do pretty much the same. So let's see how much of a frame time does it get? Oh, damn it. What? Oh, right. I've said this what word? Oh, damn it, keeping unexpected. What? It's like Skeletor meme. Identifier skipping unexpected token before lambda body. What are you talking about? Ah, damn it. What am I even doing? It's harder to make streams than it certainly feels like sometimes. It's not implicit. Oh yeah, let's capture this one. Okay. Okay. Hooray! That's why you need to make this ID working exactly. I should make a patch then. It's a pity, such a good IDE and such bad implementation for its support. But anyways, now let's get into this measurement object. Yeah, so we are not going to use the plane array. Now we're going with the apparatus style of doing things. Oh yeah, this is really slow. So these are 2 millions, and we got about 64 FPSs there. And now we get about 5. But you also shouldn't believe these numbers because there are lots of checks internally. So you really should be making a shipping build. Come on, a shipping build. Let's make it. Because the current one is actually a debugging one. And we don't need this. Two million troops. Wow. The compilation for the release build or the shipping build is actually quite sophisticated. It has some multiple passes for the linkage for the compilation stage. It can get really optimized in the end, so we gotta use it. We gotta use it as a reference. So let's get into this. Apparatus footprint, as it's called. Then we get into the builds directory, and let's launch this thing. Oh, it's appeared on a different screen, damn you. Sorry for cursing, I shouldn't be really. Excuse me. How can I make it appear on a different screen? Um, hmm. All right. Then I just hmm. Can I make it like Windows perhaps? Build Unreal Engine. Game user preferences. Where is it exactly? I don't want to do it in blueprints really. Um, oh, I see. I can actually create. Didn't know that. So many new things to know. Default game user settings. All game user settings in file. Nice. Yeah, that's surely will do nice. Okay, I hope I shouldn't really relaunch the editor, and this will do what I need. Yeah, like lots of stuff to remember, isn't it? Hmm. But I'm sure Apparatus actually like what's wrong? What you can't so you can't copy it. Why? What exactly is wrong with you? Failed to delete the apparatus exe for copy. Why? Why? Why exactly? It's not running. What's wrong with you? It's clearly not running. Okay, maybe I was wrong here. Let's do it one more time. Shall we? What? What's wrong with you exactly? So you're basically stuck on it. Oh, at least we are becoming better, learning something new. I guess this is the only way. So maybe about the new features that we'll be getting. The one is this. What's wrong with you? The packaging stage, but it's no longer here. It's already dead. Come on. Ah, such a pain. Let me get this. So if you get something like this, you go to like Process Explorer. Yeah, you're going with this thing, you download it, you save it into your downloads folder, then you open it, then you're like going like this one here, Control and X, and then you install it somewhere within. Well, yeah, 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 do it. Then open it. Then you agree, possibly, on the terms used, and then you're like this. Then you'll run it as administrator. Not this one, this whole thing. Yeah. And you're doing this thing. And then you find the process, the handle. Then you're like this one. Stupid. Yeah, and there is something stuck with this process. Let's call it even exe. Hmm? So there is no handles for it. So why can't you just remove it? Starting to make mistakes here. What are you even... What? I don't get it. Oh. Mm. All right, maybe when I load these terminals, maybe this went off. Anyways, so I should be getting... Why doesn't it show me the config? No, it's full screen again. What the... What is wrong with you? Game user settings, right? Right. So let's open. Why didn't it copy this thing into default game user settings? Default game user settings. So it's the default ones. So maybe if I did what again? Yeah. No. But I'm not running this game. Why? Something is off. No, it's not launched. It's just stuck. How does it actually do this? It's kind of ghosting process. So there are two now. How is it possible even? I really don't get it. Why? I don't see how this actually possible. How could this be brought into the system space? this is due to VR. I have a VR driver installed and basically gets all in the way of applications. Oh. Yeah, there was a dialog window that basically ruined it for me. VR is like a disease. It's kind of fun, but it's like a Trojan horse. No, it's not that simple, Alex. Actually. This is always getting in the way. This nasty VR thing. Well, it's Steam's VR thing, but there is also like global VR thing. Just oh no. Now there is this spec. No, I'm not sure even if it's related to. Oh, there is this one. So one more time. No, this may not actually be connected to the VR. While it actually had this dialog window stuck, there might be another issue. Yeah. So let's go. Where it is? Engine extras. Where is the INI file? Just need to make sure. I don't need these. Needing this. INI file, I tell you. No items. All right. Now it's gone full screen again. Okay, now. Does anyone know how to actually make this happen? Maybe What am I getting wrong here? Please tell me. Default game user settings ini. Default game user settings ini. Let's get it. This. Config folder of your root project, create default game user settings in. This is file used to tell your game its startup graphics settings. Once packaged, it will appear in the game as game user settings in. To do this, create the above file in the specified location, then put the following text in it. That's what I've basically done. This is tell your game default setup in window mode, going to information, or is window this version field. Now I'm putting it in the correct config. So it's F11 by default. Let's try this one exactly. Oh, yeah, was a lot easier. Okay, so this is now, well, this is basically the Apparatus 2 million. Is it actually shipping? Gonna double check it. Yeah, it's a shipping one. That's a shipping one. So let's just close this one to be more precise. So we're getting like about 35 FPS, right? That's exactly Apparatus operating for the 2 million subjects. Then let's just, so it's 35 FPS. Let's call it Apparatus. Well, let's start again. Let's make a shipping build for the plain array version. Well, I think it's not going to be that honest anymore, to be more specific, because there can be other stuff involved. But anyways, let's do this. Plain array. And now it actually started in the windowed mode. So now it's like refreshed the config file, so it's doing fine. And let's see it. So this is like very, very specific situation. We now get about 200 FPS with this array, but the optimization possibility for this array, for this plain array, is actually quite a bit broader than in the case of Apparatus, because it can apply some additional like parallelization or some additional SIMD instructions and things like that. But it is what it is. Can't and shouldn't really cover up this. So the plain array shipping builds versus the apparatus build is basically 5 times more efficient. Let's do this one more time just to make sure everything is correct. So let's uncheck this. Let's create apparatus. Of course, you won't be able to create a full-fledged, like, complex game with plain arrays, and you always have to like measure lots of stuff, and we are going to talk about it. What's actually managed by the apparatus and what's this footprint all about. So it's even worse. How is it possible? It was 35 FPS. The CPU is actually 20% now. How is it possible? Something's cheesy. It seems like it's no. You can't get this. This is too much. Something is definitely off here. I think it just has some instances running that are actually stale. Oh, damn it, you have a bunch of those. Yeah, just kill it. I'm not sure why they don't. Again, this SteamVR thing. It might be like interfering with the whole process. Okay, now it's pretty much silent. Okay, we can now test. Oh yeah, this is much better. So you get like about 50 FPS versus 250. So 5 times slower. Bummer. And now we're actually going to talk about what's done internally in terms of functionality. But let's just write this down. This is actually about 49, and plain array is about 250 FPS. So these are our basic stats. Both apps were pretty much CPU bound. Oh, and by the way, I should have tested it. What's the deal? What's the deal? Has it actually stopped the upper? No. It's not stopping for some reason. I can't understand. I can't understand why. Yeah, let's go to the this is not needed here. The plain array again. Whoa. Yeah, this is what the the longer I'm running this, the worse the apparatus performance gets. So it's about, actually it's about 420 FPSs. Let's write it down. I'm pretty much destroying my own product here. So yeah, about 2 milliseconds, right? And 11% utilization. Let's check this out. That's actually a bit strange. Since what's about this CPU 6 process? Is it like streaming? Let's check it out. Yeah, it's about streaming, I think. Something about streaming. Yeah, so it's basically this one. It's utilizing about 6% or so. Yeah, this is the correct one. Okay, let's run the apparatus version one more time just to make sure. Yeah, and that's about it. It pretty much stabilized at 50 FPSs. So yeah, what's about this whole thing? Why is it taking so long? And what can we actually do in terms of bringing it there, closer to this array iterating? Well, first of all, I've already said that Apparatus pretty much manages the whole entity state. So if you're like modifying subjects, modifying your entities, adding stuff to them, removing stuff to them, pretty much everything has to be done manually. So it has to be manually managed. It has to be blocked accordingly. So, for example, one of the specifics for the operating procedure is that no entity can be submitted for the processing two times. It's only one time when the entity can actually be processed during the operating strategy and operating stage. And that's very important because you can actually have your entities move from chunk to chunk, etc. And it can lose a trait. The trait can be removed and then brought back and removed again. And so the entity can potentially be processed multiple times within the same chain, because it can move out of this chain and move again. And this kind of functionality is quite sophisticated, and it's all managed internally within this loop. So there is not only these like from 0 to data size scenario, which is pretty basic, which can actually be put into some optimized registers, etc. And the actual like logic for the apparatus operating is within these like chain functionalities. When you're like beginning an entity's iterating, you basically iterate on the chains And those chains are also consistent of chunks. So they are basically chains of chunks or belts if you're talking about details, but they are like linking together those chunks or belts. And this is done, again, this is done as part of this logic. So this array, this data array, it's pretty monolithic in the end, isn't it? It's just a bunch of vectors. It's not very flexible. You can't really add any new traits, so you can't add an additional like maybe Boolean trait to this data, and it's pretty static. So it's super optimized. It's like super packed for the cache efficiency, but it's not dynamic at all. And because of this quality of being static, it can be really really optimized, but it loses a lot of flexibility that Apparatus actually provides. So you can't really, well, for some games you supposedly can, to be honest, but for certain games you just can't implement the logic on these plain arrays and leave it all to those arrays. You have to have like different structured data. So you have like maybe vector data here. Then you get some, just for the simplicity of it, int data here. And all sorts of different traits, different types data. So this is more of your like real world scenario of usage. And when you basically lock into the chain and you operate with the apparatus ECS, you basically have lots of this flexibility. Of course, you're losing some of the performance for this special case, but you get lots of flexibility. And let's say you also have, I already mentioned that, but let's say you also have some objects within these arrays that can actually be eliminated dynamically, so they can die, for example. So just about this we can write, let's say different data chunks. So this is like making it cross different types of datas, right? Datas, there is no such word, but I think you got me. So this is another thing that actually is happening here. So it should iterate above differently structured data. Then again, it should have a certain condition for the data as is it actually being deleted? Was it actually deleted? So should this entity be processed if it was deleted on the previous stage, on some previous iteration, for example? So that's another clause that has to be processed, and I want it to be clear to you. Then you're actually, if you get into the flagging functionality, it also gets in the way. So Apparatus has an additional like layer for tagging things, for tagging entities by multiple flags. It also has to be checked here. then you also like have to encompass the whole thing with a bit of a switch, because we get two types of functionality: the high level details and the lower level traits, and they can also be used interchangeably within the same operating. So you also have to like have a certain kind here. And these layers of functionality, sometimes you don't need those, sometimes, but most of the time you really do. So if you're going with some general purpose ECS solution, you always be getting these like bottlenecks, and yeah, and you always will be getting a much higher performance if you're getting like with some plain arrays, with some plain data, of course, and you have to like measure it. So, but nothing is actually quite like making. Also, if you're going with the multi-threading, you have to manually manage this. One moment. Okay, let's continue then. So, such an enormous difference really there. Да, и really in Russian. So, such an enormous difference between the plane, specific case, special case, and apparatus. You already have to like understand why that's so. So it's because all the necessary checks that are happening within within apparatus to make it general purpose, to make it versatile, to make it quite sophisticated. But we are going to provide you with the direct access for the chunks, and it's actually already there, but we are maybe going to make it usable, more user friendly, and provide some of the specific compile time flags in order to ignore all of these checks that I was mentioning before, all of those if cycles, etc., to minimize them. For example, if you are not really using or not really despawning any subjects within your iterations, or maybe you're not using the flag marks at all during your iterating process, we will provide you with the compile time templated flag in order to switch that functionality off, so that your operatings are basically flag mark checks free and other checks free. And yeah, this is gonna be a bit of a risky workflow, a bit of an unsafe workflow, let's say insecure even, but it's gonna provide you with a bit of a stronger performance power. But anyways, what can you do to make more out of it as it's in its current state? So these like additional utilities or additional functionality, it's pretty optional really for a general purpose ECS engine like ours. But I'm actually a performance enthusiast myself, so I gotta admit that we can and should allow the user to squeeze every performance bit out there. So we're going to provide this interface, this unsafe interface in the end. But what can you do now? And Apparatus is actually fine right now. Yeah, it's almost well, you can't really squeeze much or optimize much in its current state. I mean, lots of stuff is actually cached and pre-checked before even going operating. So it's really an optimized tool you've got there for this like general purpose functionality which I was mentioning before. But what can you do now? Well, you can actually go multi-threaded essentially. So you can just make it concurrent and provide a thread count. Let's start with, let's make it also a variable here so I can control it. Let's call it threads count. And let's set it to 4 by default, or even to 2. Let's go and start with 2. And that's what we are going to pass here. Frets count. Let's run this thing. Oh, I forgot I've actually changed this. Then again, switch to here and basically compile this stuff. Let's call it Apparatus 2x for the number of frets. That's 2 now. Just making sure there is no process. Yeah, so it's complete. And let's run it now. So it was 50 FPS and now it's 95, a bit like so. So we've essentially made this 2 times faster already. So let's write it down. Let's make it a perfect case, for example. And let's write here 95. Okay, let's look at the frets now. Yeah, they are far more, or at the cores, they are far more utilized now. This bump right here is because the compilation process is actually multi-threaded when Unreal Engine is compiling the shipping build. So it loaded all of them, that's good. Okay, now let's go and write 4 here. Make it 4 threaded. And let's call this Apparatus 4x. Let's make sure maybe kill this one. I'm not sure why it doesn't kill itself, but anyways. Did it actually build me a... Let's make sure. Did... No, it didn't. Seems like it didn't. Packaging complete. So where is the exe? Maybe he actually did last time. So anyways, let's start at 4x. Let's bring it out here. And let's show some stats. So for 4 cores, for 4 threads, it's now at 140 FPS. Let's say it's again making sure it's actually killed. Why isn't it always? Yeah, this can actually be because of the SteamVR thing that's showing on constantly here, but anyways, killed them for good. Now let's make it 8 core. Oh, damn it. Wrong folder. Hope it didn't delete the previous one. You might not need it anymore though. All right. Let's run this thing. So it's 2 million vector. I know that maybe internally, because there is actually a pool of threads used by Unreal Engine, and basically we're using an asynchronous task functionality. So this pool is reused, and maybe it is kept at around four threads really. So it doesn't get higher than this one. You can actually increase the pool count, but anyways. So basically we can scale this 50 FPS to about 3 times more with normal apparatus as it is right now. So you can actually, like, if you design your mechanics for this concurrent workflow, you can actually squeeze a lot more from the current state of apparatus. And you would say, and maybe you could also suggest that why can't I also do this to this array thing? I can also make it concurrent. Well, yeah, but not as easy as you would do this with the current apparatus functionality. So you're basically like changing a bit of naming here and provide the threads count, and it's all ready, and it just goes. And if you're going to implement such functionality yourself, you have to make sure that the data sets for the different threads are not actually interfering with each other. Well, you have to manage a bunch of stuff in order to make it secure. Apparatus does it for you. It does all the chunk management, chunk division, chunk range division internally. So you will be getting a safe environment that you will be operating on this environment will be guaranteed to be safe. And you will be also getting the flag marks, which are thread safe. So you can basically change the flags from one thread for an entity that's currently iterated by the other thread. So pretty complex stuff here, which can be done right out of the box in the current version of Apparatus. So I should be summing up all these things together right now. And so is Apparatus operating or Apparatus like running slower than normal C++? Well, it's C++ based, and obviously the answer could be like, how come? Since Apparatus actually internally is using some of these for loops, etc. Of course, it's not running slower than the normal C++, or this question is not really viable. But does this special case for iterating the array directly is more efficient than the apparatus's operating functionality or any other iterating, basically? Well, yeah, and it's a lot more efficient, but it's a lot more kept in terms of functionality that you will be getting. I shouldn't really repeat myself, but essentially all of the chunk and entity and different structures and flag mark filtering, all sorts of stuff you won't be getting out of this loop, obviously. You would have to do it manually, and you would have to do it manually each time you were using these loops, etc. But still, this is like some kind of a some kind of a target for us. So to be able to run these as fast as these is, of course, some kind of ideal to achieve. And sure, it will never get there, because this is quite a complex solution, quite a complex workflow to be as easy as just iterating an array. But we're going to introduce an exact and direct and raw access for the chunks that are actually utilized within these enchainings. So if you're willing to optimize your application to the bone, and if you really know what you're doing, we'll get you covered. So we don't really want to waste like any of the possibility to make it faster. It won't be actually Apparatus anymore for you for this workflow, because you'll be doing this time all the stuff manually. Perhaps maybe you'll be missing some of the functionality of Apparatus, or why it was created in the first place. But for some of the mechanics, for some of the business logic that you are implementing, this can be actually neglected. So for some kind of a loop that just maybe changes some data and it doesn't need all of these checks, it's gonna be a performance, a real performance. It could be a real performance benefit, because many systems already like base their functionality on simple arrays and are quite efficient. I mean, in the whole IT industry, so to say, because those are also cache efficient, and they pretty much natural to the hardware. And yeah, so Apparatus introduces a kind of a layer on top of these plain arrays. It introduces a certain managing like facility to be able to achieve general purpose workflow. And basically every other paradigm does that, because you could be just writing some assembly code and doesn't even and wouldn't be using even C++ in the first place, but it's not very convenient. So these like low level stuff, it has its real performance benefits, but it's not that convenient for to be a daily production driver. But yeah, this is the first thing that we are going to introduce in some of the future releases for the apparatus to make it possible to be highly efficient, a bit unsafe but highly efficient. The second one is about the new optional functionality. So when you, for example, when you like try and exactly now the previous apparatus session has actually finished. I think it's something to do with actual apparatus the initially, how does it called, apparatus destruction, because there are some facilities to unregister the subjects, so maybe it's actually my problem to fix this slow shutdown. But anyways, yeah, so the next functionality that we are planning to introduce is the new optional like traits. So it's actually partially implemented, but you will be able to ask for a trait pointer, for example, in your mechanic, in your operating mechanic, in your lambda, basically. And if it is presented in the chunk of the entity, in the entity itself, thereby, it will be a non-null. If not, it will be zero, essentially. So yeah, such as a bit of a tiny functionality, really, but it's already used by many. And I think it can be really beneficial. And actually, when you're like iterating it through lambdas now, if you look at here, these traits are not delivered in some simple way. They're not like, let's say, they are not really found each frame or each operating cycle. They actually have a precaching index for them. So this stage is actually optimized as well, and you shouldn't worry about about this stuff that each operation each operation cycle the subject is asked for this. No, this is handled quite efficiently already, and yeah, this would propagate to the optionals. Anyways, that's pretty much it. If you have like new questions or something, maybe some new ideas,